Alright, hello, greetings. In this video, we'll go through the Cambridge A-Level Further Maths Syllabus Code 9231 and Component 2, the Further Pure 2 paper. And this is the variant one from the newly released October-November 2025 Winter Series. Okay, so we go for question 1. And it's okay, system of linear equation here, x, y, z, and okay, three unknowns, three equation. So we want to find the set of values of k for which this system of equation does not have a unique solution. So if you can recall what is a matrix method to try and solve this, right? So we can decompose this into something like into a matrix where we have just the coefficient and then multiplied by the variables here, then is equals to whatever on the right hand side. So you can try to do the matrix multiplication. It does work out. You can try and convince yourself of this. So yeah. And if you can recall also how we solve, let's say we have this matrix A, B, and equals to C. So they multiply each other and this is the result, right? So to get the solution of XYZ, we will multiply both sides by an inverse. So if we multiply inverse here and inverse here, okay, so I mean the order does matter, so it should be A inverse C, right? So but yeah, the order does matter. But the point I'm trying to make is it cancel off and you're left with the A inverse and C. Alright. So yeah, what is the inverse actually? Inverse, you have some 1 over the determinant of A, and then also I forgot what's I think it's called the conjugate matrix or something, right? The conjugate of A, something like that. But maybe I write conjugate A, something like that. I can't remember what's the formula, but this is the usually what's the inverse matrix formula, right? So if it does not have a unique solution, means this is undefined. And what makes it so is that the determinant of the matrix, so the modulus of A, right, modulus of the matrix is equals to 0. So that's something that make it undefined and it does not have a unique solution. So how we solve this question? So we have yeah, we have the matrix and we can do the what we call the determinant of the matrix. So I'll just write in determinant form like that. So if you can recall, you take the I mean you can take any you can take any of the rows, but usually we take the first row, right? So we take the first row, 1 multiplied by you cover the row, cover the column, you are left with k, 3, 2, k. Okay, then you minus, right, for okay, it goes like plus minus plus and then it alternates and so on, so you have to be mindful of the plus minus plus. So therefore usually we take the first row and we just take conventionally the second column as the minus part, so minus -1, right? And uh what's the cover the row, cover the column, so you left 1, 3, 1, k. Okay, last one, so there's another one, so we can add the one determinant of cover the row, cover the column. You have 1 k, 1, 2. Okay, so for determinant, again we do the something like cross multiplication. So downwards is positive, okay, and outward is a negative. So like that, and I can equate this to 0, right? Since that is what's the condition that makes this does not have a unique solution. So we have k squared minus 6 plus k minus 3 plus 2 minus k. Right, so k and k cancel. We have a k squared equals to 7, and therefore k can be plus minus the square root of 7. Okay, so that's the first question of this paper. So yeah, we'll proceed to do the next few questions soon lah. Okay, so this is the first question. Okay, thank you for watching, and yeah, subscribe to see more of the video.